Hello and welcome to Andy's Code Vault. Today I want to talk about MonoBehaviours. A MonoBehaviour is the base class that allows you to interact with game objects in Unity. In order to use a MonoBehaviour, you have to create your own class that inherits all the abilities of the MonoBehaviour. And when you do that, you get access to lots of events and properties that allow you to interact with the game object. Alright, so here we are with an empty scene, and the first thing I'm going to do is create a game object. I'm going to create a cube. So I want this cube to do something. I need a way to be able to interact with its methods and properties. So I can go over here and mess with things here like the transform, position, rotation, and scale, and I can change it in the editor. But I really want to do something in code and be able to, manipulate these properties in code. So what I need to do is create a script. I'm going to call it the cube script. So here we have our cube script, and if you notice here, it's actually inheriting from this base class of MonoBehaviour, and that's what gives it all the access to all the properties and methods of the game object. It's because it inherits from MonoBehaviour. If I was to delete this and save this script, I still have a start and update method, and I can say debug.log. I can say cube starting. Okay, let's go back into the Unity editor. Okay, so I've got my cube script. Let's run it and check the console, see if it prints anything. Nothing. And that's because it's not attached to anything. The script gets executed, but nothing ever calls the start method. It's not attached to anything. So what I need to do is I need to attach it to the cube. But I can't do that because you can only attach MonoBehaviours to game objects. You can't attach regular scripts. This script has to be a MonoBehaviour, and you do that with the :space MonoBehaviour. Now, if I try to do this again and drag this onto the cube, take a look at the cube. It now has the cube script, and I'm going to run it, and it says cube starting, so you know it worked. So that's the basics of the MonoBehaviour. It gives you access to a lot of properties and methods that belong to the game objects and events as well. So if we go into the Unity documentation, we can look at what other things we get from MonoBehaviours. So here it mentions the major methods here: the start, update, fixed update, late update, on GUI, on disable, and on enable. But there's way more. We have these properties: run in edit mode, use GUI layout, and then public methods over here. The static method, which I've been using, called print, which is basically debug.log. And then they're calling these messages here, which I guess they are, but they're also events that you can create and override and use in your base class. As you can tell, there's a lot of them, but if you want to know the order of them, there's another documentation that shows So as you can see, this is the order of execution for the MonoBehaviour functions. So the first thing that happens is the awake method gets called, then on enable, and this is a reset. It's something to do with the editor. Then it goes into the physics mode, and in physics mode, it does the fixed update before it does a lot of the physics calculations. So if you want to know if you should use fixed update or update, if you're going to apply some kind of physics effect, you probably want to do it in the fixed update rather than update, because it'll happen before all your physics calculations occur. And then you have your mouse input, and then when you get to the game object, you have your update. Then you have all your coroutine stuff right here: yield, null, yield. This is all coroutine stuff. And yeah, so this is just a good reference. I'll put the link into the description, and you can check it out yourself. But what else we can do is we can create a script to track the events and when they get called. So we're going to call this the event tracker. But here in the update, I'm going to do the update count, and I'm going to increment that. And then in the fixed update, I'm going to call the onGUI method here, and the onGUI method or event allows you to draw and write to the screen right before a render. And so I'm going to check every second and update my counts and reset the counts basically, and then display the counts per second. So let's go ahead and give this a try, and I'm just going to go ahead and put this on the main camera. It could go on in pretty much any object, and let's take a look at our counts. So as you can see, the update is actually getting called more than the fixed update. it's fluctuating quite a bit. But as you can see, the fixed update is more consistent, and that gets called for each physics step, where my update method gets called per frame, and it's more variable. All right, let's actually do something a little bit more interesting than just printing messages to the console. Let's actually do something with our cube. So what I'm going to do is I'm going to have the cube start randomly changing colors. So over here in my cube script, I'm going to create a new enumerator called change color. I'm going to call this as a coroutine in my start method. And the reason I'm going to do this is a coroutine is coroutines get called on the same frequency as the update method. But what's nice about doing things as a coroutine is you can define all your variables that you're going to use inside of one function and just do a yield in the middle of the function, in the middle of like a while loop. Let me demonstrate. So over here, I'm going to grab the renderer from the game object and assign that to renderer. And then I'm going to grab the start color from the material color, and then I'm going to pick a random color value to change to the into color. And I don't have to define all these three as class level variables. I can keep them all inside my change color because I don't need to reference these variables anywhere outside of this method. And that's really one of the benefits of coroutines. Okay, over here I'm going to set the duration. That's going to be how long I want the change color to last, how fast I want it to change the colors, and it's going to be a random number between half a second and 2.5 seconds. Then I'm going to set the start time to the current time, and the end time is to the time.time plus duration. And now here's where the coroutine magic happens. I'm doing a while loop while time.time is less than end time. Then I'm grabbing the elapsed time by subtracting, and then calculate the percentage complete. And then I'm going to call the color.lerp. And so if you don't know what lerp is, it stands for linear interpolation. And basically it'll take a number from one value to another at its most simplest form. Like if I were to say mathf.lerp, I could lerp a float from one value to another. But in here I'm doing a color which is doing 4 different values, which is the red, green, blue, and alpha. And it's stepping through all the variations of color from one color to the other. And so you pass in the start color, the end color, and then the percentage complete. And then you do a yield return null. And so when it gets done to this loop, it's going to wait till the next update to update the next while loop statement. So when this is done, I actually don't want it to just end. I want to start a new change color. I want this to be changing colors infinitely. Okay, let's run it and see if it works. All right, we're changing the green to blue to yellow to red. Now I want to add some animation to the sphere. And what I want to do for the sphere is I want it to orbit the cube. And so I'm going to do the same thing. I'm going to do enumerator. So I'm going to grab the cube using the game object.find. And then over here, I'm just going to say while true. We're just going to do this in. And then I'm going to say yield return. I'm going to find a radius. All right, so what I'm doing is I'm taking the x value by replacing the time.time as the angle and then multiplying that by the radius. That's going to give me the x coordinate of an orbiting object using an orbit of 3. And the y is not going to change, but the z is going to be the math.sign, which is the basically in a two-dimensional plane the y coordinate, but because we're in 3D, we're using it the z times the radius. And then I'm going to create a new position. And let's see if this works. And now we got the sphere orbiting the cube. Okay, let's do something with the physics engine, and let's do something using the fixed update method. So I'm going to create a new scene here, and I'm going to call it rocket launch. Basically a capsule, and I'm going to stretch it on the Y, make it longer, and then I'm going to go over here and create an empty parent and rename it to rocket. And this is the body of the rocket, and let's give it some fins. Move the fin down here. That. There. Now we got a rocket that has some fins. It's not the prettiest rocket in the world, but it'll do. Okay, so now I'm going to create a plane. Uses my ground. I'm going to create some materials for my stuff here. Rocket material. So I can change the color. Make it a little darker. Yeah, black rocket. And the fins as well. Create a material for the ground and make the ground green. Let's make it huge. Make the ground bigger. I'm going to give the rocket a rigid body component. See what happens. And now it sits on the ground just fine. But let's set it on there. Okay, I want to give this rocket an engine. Move that engine down to the bottom, and it's gonna add. I'm gonna add particle system. Okay, let's slow down the start speed a little bit, 0.5, and then I'm gonna rotate the engine 90 degrees. Let's lift the rocket up so I can see what I'm working with. Alright, let's give it a 15 rate over time, and then the shape, cone. Make it much, much thinner. Give it color over lifetime. Like that. I think that looks pretty good for our engine. Move our rocket back down. Alright, let's create our rocket script. Alright, in our awake method, I want to create some is launch false. Okay, I've got my rigid body to hold the rigid body of the rocket, the transform to hold the position of the engine, because that's where we're going to apply our acceleration, and then the particle system so we can turn it off and on during launch. I'm going to create one more variable over here called fuel. So we're going to make this a serializable field so we can set this in the editor. But let's set a default. And then in our wake method, we want to assign our rigid body. We want to grab our engine. And then here we're going to say engine slash particle system because it's a child of a child. So I have to use that. And then on mouse down, I'm going to say is launched equals true. And I'm going to say particle system dot play. Now here comes the real magic. Fixed update. So I want to apply this in the fixed update. Okay, so I've added a new power variable to give it the rocket's acceleration power. In the fixed update, I'm checking if it's launched and the fuel is greater than 0. Then I'm going to create a force in the direction of the forward position for the game object, and I'm going to apply a force at position using the engine's position. So that's the engine that is propelling the rocket. Then I'm going to subtract 1 from the fuel. And then over here I'm going to create the update method, and in the update method I'm going to, we're launched and our fuel is equal to 0, I'm going to stop the particle system. So when we run out of fuel, it'll stop the animation. Now I'm going to grab the rocket script and apply it to the rocket, and let's see if it works. So I'm going to click on my rocket and watch it launch out of control. Okay, so I know what I did wrong. I needed to rotate the model to be 90 degrees because I wanted to use the forward position as the tip of the rocket, which is up. And so I had to rotate the model by 90 degrees, which I did. And then I just rotate the rocket back negative 90 degrees to offset that, but the forward position's going to be correct now. And then when I created the model, I initially had the engine as part of the model, which that's not correct. I need to move the engine out, and now it seems to be working. And we can look up and see our rocket just launching off into space, but it's going to come right back down. That concludes this tutorial on MonoBehaviour classes. Thank you for watching. If you want more of this kind of content, please subscribe and hit that like button. Thanks.